Hello everyone, and welcome back to Ewan's Buzz. In today's video, we're going to be repairing an HP oscilloscope that is very special to me. Reason being is it belonged to a friend of mine named Roger. He was busy restoring this oscilloscope, but he sadly wasn't able to finish it as he passed away in 2023. So, in honor of him, I'm going to be repairing this oscilloscope to what it would have been to him. This oscilloscope was also quite special to him. That's why I want to get it going again. Now, Roger was a dear friend of mine. We didn't know each other for very long, but we certainly had a good bond together. So throughout the video, I'm going to be sharing some almost tidbits about our relationship and what we did together. So let's get started. So here was the oscilloscope that Roger started to work on. This oscilloscope is an HP 54601A 4-channel 100 MHz oscilloscope. Now, this oscilloscope is nothing compared to the modern ones we have today, but it's still a very, very good one for a hobbyist. Roger did buy a more advanced oscilloscope, as this one wasn't working at the time, but let me tell you what he started to do. So, this oscilloscope is basically a little computer. It's got your RAM, your CPU, and even your clock battery. But at the time, they didn't use a dedicated clock battery, as they would leak, and when they leak, they usually damage the motherboard. So what HP did is they used something called a Dallas clock chip. Now, the Dallas clock chip is a small little, basically chip-looking thing that I actually have right here, as Roger did remove it. This is the Dallas clock chip. It basically keeps the time of the oscilloscope and all the settings that you have programmed onto it. Now, this little chip has got a battery built in. This battery runs dead over time, as most batteries do. So what Roger started to do was he started to replace it. Now, to do that, it's a bit tricky. You have to basically carve out the battery at the back here, and once you've carved it out, you have to solder new wires to it to get it to work. So this is quite a tricky job, so it will take some time. But once we get it sorted, this little chip will work again. So let's open up the oscilloscope and see where it went. So here we are on the inside of the scope. Now, I've gently removed the top cover. It does clip in, but there are 2 screws at the back, but Roger had previously removed them, so it was much easier to get in here than it would have been. So here is the inside of this oscilloscope. It's pretty small, pretty simple. We've got a power supply over here, then we've got our video board over here, which you can see if I just move that out of the way, a little video board down here. That controls the CRT, which gives you your image. Then at the front here, we've got our control board, which goes to the front here, over there. And then at the bottom, if we gently turn this over, we've got our processor board right here. So this board at the bottom here is where our Dallas chip goes. So luckily, like I said, Roger's removed it, so it's a lot easier to get into. Only downside to that is it is going to be a little bit harder to figure out where some of these connectors went, as they have been unplugged. But they do look quite self-explanatory, but to be safe, I have looked up the service manual. It's on the computer back here. So I've got it, so we can be extra sure that wherever the wires that were disconnected, we'll be perfectly sure that that's where they go back. So let me show you where the Dallas chip went. So if I flip this over very gently, we can take a look right under here onto this main board here. Now this board has a plethora of different chips on, but the Dallas chip is a specific size and also pretty noticeable. So it went right over here. You can see that it just fits straight in here. Now the one thing that I am a bit worried about, I need to just check how it goes in here, as you know, you have to be careful on which way you put it in. But it fits right here. So let me get the chip and I'll show you how it sort of sits. So, chip's back here. It will sit, I'm thinking something like this, but then again, I could be wrong and it could also fit the other way. But I have a feeling it's this way. So I'll check that in the service manual. But let's take this board out and we'll start our work on it. Alright, so now we've got the main board out. We're not actually going to be focusing on the main board just yet. We're actually going to be focusing more on the Dallas chip for now, as, like I said, it has unfinished business that needs to be attended to, because we need to put a new battery in it. Now you can't just put a new battery in there. We're going to install an external battery. So luckily I already got the bits and pieces for it, so that's what we're going to do. So let me move everything out of the way, just put it aside nice and gently, and we'll take a closer look at the Dallas chip. Alright, so here's our Dallas chip and the external battery we'll be putting in. Now this battery is designed to mount on a circuit board, so what we'll do is we'll solder some extra wires onto there just so we can get it out and connect it to this. But let's take a look at the Dallas chip. The Dallas chip is a non-volatile RAM as well. And that always needs power to save its information, because if it doesn't have power, your information's gone. So it's RAM and a clock as well, which is pretty neat. But let's look at the back. As you can see, Roger already started chipping away at the adhesive to get to the battery. But that can be a bit tricky, so I'm going to use the Dremel, which will very slowly take away the adhesive around there so that we can get a closer look at the battery. So I'm going to do that. It will take a while, but I will make it as a time lapse so you can see exactly how I do it. So let's get started. Okay, so the removal process is going well. It's just creating a lot of dust. But it turns out this has 2 batteries, which is very interesting. So this thing might run on 6 volts. So we might need to combine 2 of these. Luckily I have got 2. So we might need to combine them. But let's continue. This has been taking a while, but it's been worth it. So let's get that other battery out. So here we are finished, and luckily it only had 1 battery. I thought it had 2, as the text had actually imprinted on the stuff, on the resin they put in. So, but we're finished now. So we've got the 1 battery out, and it's a lot smaller, as you can see. But for curiosity's sake, let's see how much power is still left in it. So we'll set that to volts DC, and let's give it a check. So this side is positive, and this side is negative. Yeah, 0.3 volts DC. That is not a lot. And the Duracell, which we've got here, okay, that's because I got the polarity wrong. There we go, 3 volts. So that's what we want. So sadly, this little guy's dead, but I have exposed the contacts as to where to solder onto. So we'll be doing that. It is very, very tiny, as you can see right here. You can just about make it out. There's a little point there, and then there's a little point there. So I'm going to be soldering those on, and I know that this point is negative and that point is positive, judging by the way the battery went in, as it sort of fitted in like this. And as you can see, so you can see where the negative and the positive went there. You can kind of get an idea. So I've got these 2 little wires that I'm going to take the insulation off, and we're going to gently solder them in. So let me prep everything, and then we'll get to soldering. Okay, so everything is prepped and ready to be soldered into the chip. Now, these are my little wires that I'm going to be using. One's going to go onto the negative, the other is going to go into the positive. So let's do that. Such a South African sound, isn't that? Oh, man, they're noisy. But anyway, let's continue. So, this little procedure is basically going to remove the battery out of the chip, so that when it does die again, you can replace it. So that's why I'm soldering these little wires up to the contacts. So let's gently move that in there, and just solder these on. So in the beginning of this video, I mentioned that I'd be explaining some memories that Roger and I made. And one of those was, well, actually, let me explain to you how we met. So I had bought my very first car. It was a Mercedes C-Class W202. Beautiful car. And it turns out Roger was actually repairing a similar one, but his was just a bit newer than mine. From 2004, that's when his was made, I'm pretty sure. And so we got to talking, as when my mum mentioned in her German class that I had a Mercedes, Roger actually said, "Oh, guess what? I've got one too." So later on, we met up, and he showed me how he was working on his Mercedes. And after that, it was really amazing to meet someone that also really enjoyed what I enjoyed. So over time, we went to his warehouse, we did some projects together, we did all sorts really. But then eventually we still continued, but then sadly he passed away. I think some of the notable things that we did together was we went to his warehouse where he's got all of his really cool tools, and we saw what he was working on there. Another time was, when was it? We went antiquing. I found some very interesting things with him. That was really, really fun. I enjoyed that. And another time we went and we built a geyser manager project together. I don't know if he was able to finish it, but we did work on that together, which was really fun. And he also helped me with some of the problems on my car as well, as there were some issues here and there that I needed some help fixing, as he's also got an OBD2 port reader, so he helped me out with that. And yeah, he's done amazing things. He actually asked me to help him video the restoration project that he was going to undertake. It was his dream to restore a Spitfire aircraft. And man, that was one awesome dream. And it wasn't just a dream. He actually made it come true, as he bought a whole lot of parts for the thing. And he really got it. He was close. I mean, it would have taken years, but still, he was close. And I felt honored that he wanted me to document the whole procedure. And sadly, we didn't get to there. I would have loved to, especially now. I've got all my new camera equipment. It would have been amazing to document the whole experience. But then again, time is always of the essence, sadly. So that's why this is just a little thing that I want to do in memory of him, as he honestly deserves it. So I've soldered the wires into the chip, and they're all connected up, as you can see here. So let's connect them onto the battery holder. So another thing, something very interesting. Roger told me that this oscilloscope was one of the first oscilloscopes he'd ever used. That is digital, of course. He had used analog ones, but this one is digital. So this was the first one he'd ever used, so it was quite sentimental to him. So that's why I really want to get it going, just to show my respects to him. And so if you want to know, now what I'm doing is I'm taking heat shrink, which is this stuff right here. It's like little wires that slip over so that these wires can't touch anything. So what we're going to do is we're gently going to pop out the battery with a screwdriver right here, as it should just come straight out. There we go. So this is a clip-in battery holder, not a spring-loaded one. I thought it was a spring-loaded one. Oh, but that's really nice. Inside the battery holder, it actually tells you the polarity. Positive at the top, negative at the bottom. So that's really nice. So, let us connect it up. So I've labeled everything, but we'll start with positive first. So what we're going to do is we're going to tin the wires. Well, I've already tinned the wires. We're going to actually tin the contacts on here, as I forgot to do that. That's why I took out the battery, as tinning is... It takes a bit of time, and it is also very hot. So, and heat tends to damage batteries, which is not good. So let us, first of all, slide the heat shrink over. So I've also color-coded the wires. So you got your positive, which is the red, and your negative, which is the gray. So the gray will get the black heat shrink. We'll just slide that right over. And then the red will get the red heat shrink, or the positive. So there we are. Okay, so the heat shrink's on. Let us solder everything up. So let's do the positive first. So I'm going to actually grab these little guys, which will just hold this in place and make it a bit easier to do. So as you can see, I've got the holder here. Let me just center that up. There we go. And we're just going to flow some solder onto the wire, like this. There we go. So I'm just going to add a little bit of extra solder, as it looks like it was a bit sparse on the wire. A bit scarce, I should say. Much better. There we go. So now there is the positive side done. Let's do the negative side. So I'll also put a bit more solder on here as well. There we go. And there we are. So our wires are done. So now our external battery holder has been attached to the chip, which is really nice. So we're just going to gently slide the heat shrink over, and then we're going to shrink it up, and I am just going to put this on top of the chip, and we'll leave it at that for now. Then I need to straighten out all the pins, clean them up, and we can put it back in the main board. So I'm going to do that, and we will continue on. Now what we're going to do is we're going to put some hot glue in here, just so these wires can't pull out by accident or something like that. And I'm going to put the little battery holder on top of the chip, so then it's just sort of there and out of the way. Now, looking at the motherboard, it turns out there's a little spot that aligns with the spot on the chip, so I know which way it's meant to go into the board. So, I'm going to put some glue in here, and then we will install it into the board. So let's do that. Okay, so the chip is all done and ready to go back into the motherboard. As you can see, I've cleaned off the pins, and I've put a little bit of glue where we hollowed it out, and I've just glued the battery holder down to the top. So it's all nice and solid. So let's put it back in. So what I noticed was there's a little dot on one of the pins on the board here that tell you where to align the chip so you don't put it in wrong. So let's quickly put it in. So the chip is back on in there. There we go. So now let's flip the board over and do some soldering. And there we are, we're finished. So let's flip this over and see how it looks. And honestly, it does not look too bad. So let's put the battery in. So the battery just clips right in. Very simple and easy. Just like this. This battery holder is a bit tight, but there we go. There we are. And the battery is in place. So now this chip should in theory be active. So let's put it all back together. Now, interestingly enough, I did notice right over here, this component is looking like it's been knocked off actually. So I'm going to gently put it back on with my soldering iron, and we will then start putting it all back together. So let us quickly do that. So this is an SMD component, so I'm actually warming up my much smaller soldering iron so that we can get it all sorted. So as you can see here, let's see, there's our little problem component. Let me zoom in the camera so we can see what we're actually looking at. Alright, so now you can see this teeny tiny little component right here. Just comparing that to my finger, that's pretty small. But you won't believe it, they get much, much smaller. So, this little component has been pushed up, which can sometimes cause problems. So what we're going to do is we're going to heat up the pad at the bottom there with this little soldering iron here. And we're going to flow some new solder onto that pad. Okay, I'm gonna actually remove it because that is not good. The fact that it's burnt up like that. So let's quickly get it out. There we go. 105, okay. Let me see if I have a spare capacitor like that and replace it. Okay, so after some searching later, got great news. I managed to find a 1 microfarad capacitor. As I just took the value of one of these capacitors that's already on the board, like these two here, I took one of them off, which was actually this one over here. I took it off just to get the value. So now I've got the value, and I managed to find an electrolytic. And it is different. That's because it's an electrolytic, and these are, I think they're film capacitors. But even though they're surface mount, I can still mount this electrolytic onto where it used to go, which was right here. The nice thing is the board is labeled positive and negative, which is very important with electrolytic capacitors in particular, like these, because they can explode if you don't wire them properly. So let us prepare our new capacitor. So the short lead, which is this little one right here, is our negative, and it even says striped along the side there, and the long one is our positive. So what we're going to do is we're going to gently bend them, as you can see here. Our once surface mount capacitor is now an electrolytic through hole. So what we're just going to do, we are going to cut the legs off as they're not needed anymore. So we'll just gently snip them right off. There we go. That's the one side, and here is the other side. Oh dear, it has come unsoldered. That is not good, but not to worry, we'll just reattach it. Hopefully a bit better this time. A little bit of extra solder on there, and just push that down in there. Push that down as well. Much better. Now it's solid. And then hopefully we can just gently snip it out, as we don't want this leg shorting out on something else, because that would not be good. There we go. Now our capacitor is in, which is looking pretty good if I just focus up on it there. So now our capacitor is in, and that was actually the only other problem I really noticed on this guy. So we can start putting it back together, as all the little extra things we've had to do are all sorted. Now the capacitor that I did remove to check the value I might replace, we'll see if it needs to be, but it shouldn't. So I'd say we can start putting this back together. Okay, so before we put it back together, there were a few things that I noticed on this side of the scope, no longer the main board, on this side, which is the power supply and the display board driver. So let's flip it over and take a look. First of all, see all these in here? They are potentiometers, but not any type of potentiometer. They're actually rotary encoders. Now, these little guys do tend to get dirty over time. So we're going to use some Contact 60, which is like a contact cleaner, just to clean them up. So I will clean those as well. And also just in general, it's a bit dusty and dirty in here. So what we'll do is we'll give it a nice clean, and we'll come back to it being nice and clean. So let's do that. Alright, so now the cleaning process is done. You were probably wondering what that white gooey stuff that I was rubbing off with the paper towel and electronics cleaner. Well, that was actually old rubber feet, and what rubber tends to do when it gets old is it tends to turn back into oil. pretty much, like an oily goo. And that stuff is very sticky and also very hard to get off, but I find electronics cleaner works great to get it off. No isopropyl alcohol or anything like that. Electronics cleaner works well. As there was a lot of it on the bottom of the board, now it's all gone, and the worst of it was underneath here. And now it's clean. And you can see these were where the rubber feet were, and they had literally just gone and turned into goo. They were just little white rubber feet to stop the board from touching anything. The board shouldn't touch anything, but I will see if I've got any of these feet, and I'll, just pop some back just to make it complete. But it doesn't need them if I don't have them. But if I do, I will most certainly put them in. So we can start with the reassembly. So yeah, let's do it. Alright, so before we start putting it together, I know I'm keeping you in suspense, but I do have little felt feet. Not rubber ones, but felt. I mean, felt's not conductive. So just to put it there, they're not as tall as the old one, but they will still be there just in case. So let's quickly pop them on. Nothing hectic, just some little felt feet that will just go here. There's one. And then there's the other one. And the last one, which will go here. And that's pretty much where all the feet were. So now we can start putting it back together. And there we have it. We're done. It's all back together. Now let's plug it in and power it on. Hopefully it runs through its self-tests okay and works. So I'm not going to put the expansion module on just yet, as we want to make sure it runs all its tests without picking up any errors that could be caused by this. So let's turn it on. Okay, we've got fans. That's a good sign. Let's see if we get display. Oh, we do. Oh, factors, failed checks and test default loaded. Failed checks and test defaults. Hey, well, we're getting a picture. That is great. It is giving me an error, so let's see if we can clear it. should be ready. So let's grab a probe and see what we get. So I'll hook it up to the calibration signal, and this is on channel 1. So we'll hook that up there, and we'll set that to 10 times, which it is. Okay, let's hook it up and see what we get. So, channel 1. Oh hey, we're getting something. Okay. Oh, that's for channel 2, my mistake. Time per division, there we are. It's working. Let's change the position. There we go. We're getting the calibration signal. It is working. Okay, that is fantastic. We've got it working. So, now, why don't we get another probe and see what's happening on channel 2. Okay, so it is a little bit finicky, but that is great. It is working, and the fact that you can actually see it through the camera is also really good, because usually CRTs tend to flicker quite a bit. But we've got it working. Isn't that incredible? Well, let me get it stable. There we go. Okay, so I just went into manual trigger and changed that around. But it is working. Now, I don't know about we didn't get any clock errors, so I'm pretty sure the clock seems to be working as well. So let's power it off and power it back on and see what it does. It didn't give us any errors, and it booted up without, it saved our settings. It did too. Scar trigger mode? Yeah, it saved our settings. That means it's working. That means the fix worked. Oh, would you look at that? We've now got a perfectly working digital oscilloscope. Now, the image looks about right. I don't know if it's meant to be this small or not. If not, let me know in the comments, but would you look at that? It works. So now let's do an exterior clean, and we'll get it up and running. Let's check other channels as well. Just check. And we'll turn channel 1 and channel 2 off. We'll go channel 3 and channel 4. There we go. That's the mistake I was making. I wasn't source 3. There we go. So now it should trigger. Ooh. Okay. We've got a CRT issue now. Oh yeah, that's not good. Not good at all. Okay. Let's power it off and see what the story is. Okay. Oh yeah. Okay, we're getting our signal. It's just not wanting to trigger. Yeah, we're good. On both channels, we're good, yeah. Okay, so the channel side of things is working, but now we've got a CRT problem. So let us take a look at what that might be. It could just be a loose connection, as this looks to be loose connection behavior. So let's turn her off. Or we can try turn her off. There we go. Plug her back in. Turn her on. See, maybe a power cycle fixes the problem. No, we're still getting this problem. But it didn't lose its settings, so we know our clock chip fix was good. But let's open it back up and check what is happening with the CRT. Now this is pretty cool. We might go into some live troubleshooting to see what quite is happening with our CRT. But let's turn it off and open it back up. Okay, so now we've got it open. The reason why I use one of these paint scrapers to open these sort of things is because since they're so wide, they don't dent the plastic and you can easily just sort of wedge it open, as the case does just slide off, but it's old plastic, so you want to be very careful. So, let us take a look at our CRT board, which is right here, covered by this little piece of paper. You can see it hiding over here. Now, there's one thing that, it could be a pretty simple issue, nothing major. It looked like we were having a vertical hold problem, which should be adjustable from inside. But let's do some basic things before we turn it on. Like the first thing that I'm thinking we do is we clean out the connectors, as we have no idea how dirty these connectors might be, inside. So let's do that. I will just spray some contact cleaner inside and just push the connectors in and out a little bit, which might clear them up, hopefully. But then I do also notice the neck board is a bit skew. Maybe I bumped it while I was, messing about with, turning it around and doing all that. So I will also try and just also do the same on the neck board, some contact cleaner for the CRT contacts as well. And also the coils, and we'll see where that gets us. So let's get started. cleaned all the neck board connectors and all the power connectors and all of these little things. So let's see if that has made a difference. So now I must warn you, when you're working on things like this, especially oscilloscopes or CRT monitors, anything that has a tube screen like this one, you need to be very, very careful inside, as they do work at very high voltages. So I'm going to keep my distance and be very careful, but let's take a look at what it does when we power it on. So here we are. So it's live now. Let's power it on. Alright, the fan's kicked on. It's a good sign. Okay, heard a relay. Okay, there we go. Okay, so there's no problems, but that image is still very small. I wonder why. Too bright. Okay, so that's brightness. Vertical size, here we are. Whoa, okay. Interesting. Seems to have some sort of vertical size problem. So, the capacitors. Now this is a common thing in all the electronics, so we will have to take this not capacitor board, but the CRT driver board out, and we're gonna look at what capacitors are there and what ones may need to be replaced. And we'll see if I have them. If I don't, I'll have to order them, but let's see what's happening in here. So let's do that. Alright, so editing you in here. I noticed the video was getting a little bit long, so what I've done is I'm going to cut it into two parts. So this is part one, and I will take out that board and you'll just see me take it out, and I'm going to cut it here, so then we'll start looking at the capacitors and fixing that capacitor board in the next part. So for part two, we'll start looking at capacitors and fixing it up. So I hope you'll join me for part two, and I'll see you in the next one.